Alright, so in this example problem, we have a wooden board. So I've drawn the wooden board here that has a weight of 200 newtons. And remember, for a homogeneous symmetric object, we are going to apply the force or the weight of that object at the center of the object. So I've drawn my 200 newtons pointing down at the center. And I've labeled in here the length of the board. And it's hung horizontally with a rope at each end. So we have a rope here and a rope here. So I'm going to call the tension here force of tension 1 and the tension here force of tension 2. Additionally, there is a large box sitting here, and it is 0.5 meters from the end, so I've labeled the 0.5 meters here. And remember, we need forces, not mass, so whenever I plug this in, I'm going to do m times g is equal to the force of gravity of that particular box sitting there. Our goal in this problem is to find the tension in each rope. So we have force of tension 2 and force of tension 1. Now if I try to go straight to Newton's laws, so sum my forces, we end up with this relationship here. And the issue is I don't know force of tension 1 or force of tension 2. So summing my forces is not going to work for starting this problem. So I'm going to try summing my torques. So we're going to have a torque from tension 1, a torque from the board, torque from the box, and a torque from tension 2. Now I have to pick where I'm going to set r equals 0 at. And I've chosen to set r equals 0 here at the left end of the board, where the force of tension 1 happens to be applied. That means that when I take force of tension 1 times its r value, I get 0. This causes one of the values I do not know to drop out of the problem. I then do force times lever arm distance, or force times r, for each of the torques. Now notice I made this one negative, but this one is positive. This comes from applying our clockwise and counterclockwise rules. So if this is my rotation point, I'm pretending r equals 0 is my rotation point, even though this system is not rotating. Imagine this force would push down on the board and cause the board to rotate clockwise if it was the only force there. The same thing with the weight of the box. It's going to push down. Remember, this is your fixed rotation point. So this is also going to cause clockwise rotation if it was the only force applied to the board. This one, on the other hand, pulls up. So it would cause counterclockwise rotation if it was the only force applied. Remember, we're pretending it's rotating around this point. So that's why this is negative, because these are clockwise, and this is positive because it is counterclockwise. I've now plugged in my numbers, so we have the force from the board, or the weight of the board. Now I plugged in 1 meter here because I'm doing all of my r values relative to where r equals 0 is. So the distance between here and here would be 1 meter, because this is essentially distance from one end of the board to the center of the board, so half the length of the board is 1 meter. I'm plugged in the mass times 9.8, so that I plug in the weight of the board, or not the board, the box. And then I'm multiplying it by its r value, so the distance between here and here. So this is 0.5 meters from this end, and the length of the entire board is 2 meters. 2 minus 0.5 is 1.5. And then finally, this is my unknown here, and then 2 meters, because r equals 0 here, and the force of tension 2 is applied at the other end of the board. So that'd be the full length of the board, or 2 meters. So I solved for force of tension 2. Now you could go back and use this concept again to find force of tension 1, setting r equals 0 over here this time, so that force of tension 1 doesn't drop out of the problem. But rather than having to refigure out my lever arm distances, or R values, I'm going to use this relationship I already have written down here, summing the forces. That way I don't have to figure out lever arm distances. So I'm looking for force of tension 1. So I plug in the weight of the board, remembering that it's going to be negative. So the sign rules for torque and force are not the same. So in this case, the signs happen to be exactly the same, but that may not always be the case. So always check. The weight of the box is also going to be negative because it acts in the negative y direction. And then the force of tension 2 is going to be positive because it acts in the positive y direction. So this allows me to solve for force of tension 1. I do have additional example videos already recorded in the example videos link that is already in the Unit 4 folder. So if this wasn't enough example for you, I encourage you to check those out. We're also going to practice this in Lab 112.